last session of the day. There's a saying in Venezuela, okay, where I'm originally from, that's called "La hora del burro," and what that means is literally, quite literally, the hour of the donkey. Now, it doesn't have anything to do with donkeys or anything at all. I mean, its meaning is basically it's the sluggish time of the day, right? Everybody's tired. It's the last one. You've already had lunch, so it's a difficult one, but we'll get through it. Okay. I want to start by introducing myself. I'm Jose Andres Rodriguez Perez. I'm originally from Caracas, Venezuela, but I work in Belgium at Inatum, where I'm an Azure cloud engineer. Okay, I fell in love with the Power Platform, and then from there, drifted away into the Azure ecosystem, and here we are today. Okay. Now, I want to begin by asking: is there anybody who is a football fan? Somebody who loves football, or maybe just loves video games? Nobody likes football. Nobody likes video games. Okay, good. The reason I ask is because I'm a very big football fan. Okay. Yesterday I was watching the game between Atlético de Madrid and Real Madrid. I don't know if you guys saw it, but it was a crazy match. And every time I see those intense matches, I always want to try to emulate it in a game. Okay. So I'm a big fan of eFootball specifically. I know that there are some people who like FIFA, some people like Perez. I like eFootball because it seems just a little bit more real, okay? FIFA is a little bit animated, at least in my opinion, okay? So I saw the game, right? And I wanted to play, and then I thought to myself, you know, this is a game, but there are a lot of things that are into play, okay? And, you know, we have matchmaking, okay? So there are two people that are connecting to play a game. We have real-time gameplay, so if I see Mbappe running to the box, I want to press whatever button is the pass button to get him the ball in time and hopefully score. There's also player stats and teams. If you've played these games before, you know that you have you know, the stats of the players, who's faster, who has a better curl, that kind of thing. And of course, the teams, they have to be updated with the current day. You have microtransactions and my club, so you can buy players. I mean, you can buy your cards and build your own team, so it's very fun in that sense. And of course, you have game updates and live events. So when the Euros come up, the games throw a patch, right, so that everybody can play with the latest team and the latest stadiums and so on and so forth. So if you think about it, there are a lot of things going on, and it's quite a complex system, right? You have a game client with eFootball. You can play on your phone, you can play on Xbox, on PlayStation, and FIFA, of course, you can do that too. You also have the matchmaking servers, right? So the ones that finds the opponents, where you, the people that are going to play a match. You have the game servers themselves, right? So the ones that handle the real-time actions, so the passing, the running, and all that. Databases for your stats and your teams. You have payment services, so when you want to buy a card to have a better team for yourself. And all of that has to be hosted in some kind of cloud infrastructure, okay? So it's a silly game, but if you think about it, there's a lot going on behind it, right? And sticking to cloud infrastructure, you want to make sure that the game is very performant, right? So you want to make sure that players can connect to the nearest region so they don't experience lag. If a server goes down, then you want to reroute that traffic to the closest server so that the user doesn't experience any kind of downtime. And ultimately, you want to prevent outages in general, okay? So deploying to multiple regions is very important because it reduces lag, it improves stability, and it ultimately prevents major failures, okay? But what happens when things go wrong, okay? So you're in a game, right? You have high ping, you have laggy matches, the network is congested, there are many people playing in the same servers. The matchmaking takes forever, so you're just waiting in the lobby, hoping for somebody to join you so that you can play the game. or you're maybe in a very intense match, the final of a tournament, and suddenly your connection drops because there was a disconnection mid-match, right? So a cloud region failure. Or you just bought Mbappe with the highest stats and it cost you 30 euros, and suddenly the transaction didn't go through. So you don't have your 30 euros and you don't have Mbappe. Now, I know that this is a very silly example, but this is a very serious business, right? So just to give two examples, there was recently a PSN outage in February, right? And many people were impacted, and many features within it. So, the social features within PSN, the PlayStation Store, and as compensation, the user received 5 days of extra PSN, right? Of PlayStation Plus. Okay. Of course, that's still a little bit not as big, you would think. But what about a bank, right? So a bank, specifically Barclays Bank in the UK, suffered an IT outage, and this hasn't been the first. There has actually been many more in the past 2 years. Actually, 158, and you can look it up. This is just the first thing that popped up, but there are thousands of articles saying how Barclays apparently is going through a very tough time, right? And in this case, this IT outage was due to a software problem in their mainframe, okay? So it's very, very important to take this into consideration. So these are all outages that were out of our control, in a way. But what if we could simulate these failures, right? What if we had the power to inject failures and build upon that, okay? Or try to better develop our systems to support these kinds of failures. So some guys at Netflix were crazy enough to develop a tool that was called Chaos Monkey, right? And this tool would randomly terminate VMs, instances, or containers in production, right? And they did this, of course, to try to emulate real-world events. So what if a container went down? Can people still stream? Can people still watch their movies and TV shows? So all of this got me thinking, and it turns out that Azure has an offering, which is Azure Chaos Studio, okay? It's a managed service by Azure, and it helps you to implement chaos engineering. If it isn't clear already, chaos engineering is basically the practice to try to inject failures in a controlled setting, in a controlled manner, okay? So with Azure Chaos Studio, you can test resilience in your systems, like against real-world incidents, right? So outages, high CPU utilization, DNS errors, issues, that kind of thing. And we will see some of what Azure has to offer with this resource, okay? This is done basically by creating chaos experiments, right? Which describe the faults that you want to run in your system. Now, in Azure Chaos Studio, there are two types of faults that you can implement, okay? You have service direct and also agent-based. And what that means is that with service direct faults, they run directly against the Azure resource. While agent-based, you have to install an agent in a VM, okay? This is very important because you will see that in the library, in the possibilities that there are to inject these failures, they depend or they vary according to the resource. So for example, for service direct faults, you can reboot an Azure cache for Redis cluster, or maybe add network latency to an AKA's pods. And for agent-based faults, you can inject failures directly to your virtual machines, right? So virtual memory pressure, kill a process, shut down the machine, and not just for VMs, but also for virtual machine scale sets, okay? On the right, you have an image which I'm not sure if you guys see it very well, but we will dive into it in the portal, that describes what conforms a chaos experiment, right? So you have steps and branches, and within them, you can describe the type of faults that you want to inject, right? Some can run in parallel, or some can run sequentially. So all the faults that you can add within a step, for example, in step 1, will run at a particular time, and then once all of those are finished, the ones in step 2 will continue, and so on. And in branches, they'll run in parallel, okay? But we also have to talk about targets and capabilities. So you want to inject failure in your system, but not just anywhere, right? You want to have a blast radius. You want to have a controlled way of just killing this virtual machine, or maybe affecting this particular resource. You want to have control over which resources are affected, right? So what you see on the screen are just a few of those faults that you can use. They've been cherry-picked, but there's a whole library, and it depends on the resources that are available at the time. So for example, like I said before, for virtual machines and VM scale sets, you have CPU pressure, you can kill a process, add network latency, DNS failures, and so on, and there are many more for them. But for example, for app services, you only have one, which is to stop the app service, right? And the same applies for NSGs, right? You can include an NSG rule at a particular time to see how the network behaves. That's also something that's available. And you also have some other faults for AKS, like network disruption, container disruption, and time sync issues, okay? So let's take a look at the portal, just to give you a brief idea. Give me one moment. There we go. Whoops. All right. So what you see on the screen is you go to Azure, you search for Chaos Studio, and this is the designer that you get. So you can define the targets, as I mentioned before, in the subscription that I have available. These are the resources that you can inject faults to. I've already prepared a demo, so I have some of those resources already enabled and activated. So for example, these app services are enabled just for service direct faults, but not for agent-based, of course, because they're not VMs. But for the ones that are VMs, I've enabled both, right? So for the VMs, again, you can cause a disaster in terms of all the faults that you can inject. But for the demo, you'll see that it's something actually very, very simple. It's nothing too crazy, okay? So you can define the targets here in this panel. And then in your experiments, as we saw in the image, you can define or describe how the faults are going to take place, right? So this is just a silly example where you can see that I have two steps, right? So the first step being to kill client services. And I want to kill the clients in, oops, hold on. There we go, maybe too much. My client's in region A, right? So I'm gonna stop an app service for 10 minutes, and it's just one resource that's going to be affected. And then at the same time, I also want to kill a client, stop the app service in region B, right? Where it will be for 10 minutes, and it's just one particular resource. And for the backend, oops, it's basically the same. What's wrong? Put it too big, probably. Yeah, is that the case? Oh, God. Thank you. All right, so let me see, just like this. Yeah, this is better. Okay, and then for the backend, it's the exact same thing, right? So I want to shut down a VM for 10 minutes. It's just one resource. And then I want to cause a delay for whatever reason. And the same for region B, right? So that's just a sample experiment. So for the demo that I've prepared, there we go. I built a small demo, right? It's just a very simple app. It's actually rock, paper, scissors, which I'm hoping, I'm aspiring that all of you will be able to play, okay? Where you have a link, right? And I'm using Azure Front Door as the external load balancer that will redirect traffic to either an app service in West Europe or traffic to North Europe, and then an internal load balancer for the servers, right? So one is in West Europe and the other one is in North Europe. So it's a very simple, um, demo. What I'm gonna try to do is to kill the VM that's in North Europe, right? You guys should still be able to play, and then ultimately kill the one in the other region, and you just won't play at all. I mean, you'll see the game, but nothing will be. You won't be able to do anything. Okay. So I want you to help me by scanning the QR code that you see there. I'm taking a huge risk, but play big or go home. And what you will see is this very simple app. I suggest that you guys play it horizontally in landscape mode because I don't play very well with front-end technology, so bear with me, okay? So you'll see two buttons, one that says play with a friend and the other one says play with a stranger. If you all click play with a stranger, you'll be paired with somebody in the room, okay? And the best out of 3 matches ultimately wins. So I'll let you guys play for a moment, and while you're playing, what I'm gonna do, oh God, what happened? Okay, what I'm gonna do is run one of the experiments, okay? It's gonna take some time. I want you to see how it works, but I'm gonna show you already a short, how do you call it? A very small metric of the VM shutting on and then shutting down, because it takes some time to run the test, and that's not the purpose of the demonstration today, okay? So it's running in North Europe. What should happen is that you should be able to continue playing. In the case that that your game was hosted there, you'll just have to refresh the page and load it again, because there's no like a session kind of thing going on that if it shuts down, it'll redirect you to the other server. It's not as fancy as that, okay? So it's running. That's gonna take a while. And just for the sake of it, I'm gonna run it in West Europe 2, and it's gonna kill the game at some point, okay? You'll see that it starts to lag, you won't be able to continue playing, you'll select a choice, and basically the game will die at that point, okay? So I'm gonna leave it there while you guys are playing, and just go back to the metrics that I wanted to show you, okay? So if I click the last 30 minutes, maybe not last 30 minutes, maybe 1 hour. The 4 hours, maybe. Oh man, it's not loading. Give me one moment to see. Take some time. But anyway, the point is that you can see that once the test runs, the availability of that VM goes down, and then when the test is finished, it'll go back up again. Now, this is something to take into consideration, is that this will break your system. So you have to implement a strategy of just injecting failures, maybe in a subset, in a production setting, right? Where you can control if a service goes down, this is exactly what you want to do. Or maybe do it in a sandbox or in a testing kind of environment where you can, it doesn't really matter if something breaks too hard, I would say, okay? So that's something to keep in mind. It will break the resources that you have implemented. It's not just something that's not happening in reality, I would say, okay? So at some point you'll stop playing, and that is virtually it. So there are key takeaways regarding this, and it is that Azure Chaos Studio enables you to inject safely, right, faults to test real-world scenarios. You can define the blast radius, just specific resources, specific VMs. There's no need for custom scripts. You have the portal, but you also have available a set of APIs where you can leverage them in your deployments, right, or in your testing in general. And ultimately, it provides a proactive approach to reliability, okay? So the best way to practice failures is, to handle failures is to practice them, whether that be in Perez, in FIFA, in your cloud and enterprise infrastructure, or maybe just in a simple rock, paper, scissors game. All right? That is entirely it. I welcome any kind of feedback. This has been one of the very first sessions that I have given. It's been an absolute pleasure. I do this to learn and to share my stories from the trenches, if you say it in some way. Okay? So I highly appreciate your time, guys, and I'll meet you at the drinks afterwards. All right? Thank you very much.